Hi everyone, this is Navneet and I am currently pursuing BSc Honours in Data Science and AI from IIT Guwahati. I am also doing a research internship in facial emotion detection at IIT Guwahati itself. And this video is the submission video for my internship 3, course code DA379 in trimester 9. In this video, I will be demonstrating the work that I had done during my internship 3, which is a extension of the previous internship that I am doing from the March, and it is almost 5 months from March till now. And in the phase one of my internship, I had compared different type of handcrafted features like HOG, LPP, SIFT, which are basically histogram of gradients and linear binary pattern, scale invariant Fourier transform. Then later on we are passing that through SVM classifier, and we found out that HOG was the strongest descriptor among all these. And later on then we tried deep learning techniques like VGG16 mobile net. In this, we had done one thing, that we had removed the final layer softmax, and instead of softmax, we had used SVM as the classifier, and we are just using it for extracting image. And we had tried different combination of handcrafted and deep learning features, and we had fused them hybrid, and tried different permutations like HOG plus VGG, HOG plus mobile net, VGG plus mobile net, HOG plus VGG plus mobile net, and many more. And we found out that HOG VGG16 mobile net, when we are concatenating all these three all together, we are getting the best overall accuracy. But there were two major problems, like it is treating every feature and every emotion at the same way, and it is doing all the time. And to reduce the gap, we found two major problems, like that it is trusting every prediction equally. For example, if an model is unsure about an face, or it is just doing random guessing for an particular emotion, it is reporting result with full confidence. And for the second one, it is treating every emotion the same way, like when we were fusing the models, we are using the same for each emotion. So to solve this, we found two solutions, like SVM aware awaited fusion. In this, firstly, I had done like I had given more weights to HOG and mobile net than VGG. I had demonstrated in the phase one of my internship that HOG and mobile net are contributing more than the VGG. So we had tried different manual weights and accuracy learned weights, almost five weights uh, to give to do the SVM aware weighted fusion. And in the SVM aware weighted fusion, we came up with an idea that we will check at different threshold, and if the probabilities of our predicted values is below some threshold, we will reject those samples. And for the idea too, like every image should found its best detecting model or facial descriptor at itself. And we will train every feature combo as a separate, so that it can found the expert model for it. And I had done five-fold cross validation in this, so that there is no chances of overfitting, and we will pick the best expert individually for every emotion. So just giving a quick refresher about feature extraction. As here you can see that HOG mobile net VGG16. HOG basically capturing the edges, eyes, brows, mouth, where there is an lightning changes or some edge, then it is giving that place as a texture, and it is not considering illumination changes. So then we used mobile net and VGG16 also. These are pre-trained models. We had removed these final layers and just used them for extracting features. And these there is no need to do manually extraction in this. It will automatically do this. And then we had standardized these, so that no single feature dominates just because of the row scale. So for the idea one, SVM aware weighted fusion, So different, I had given different weights to HOG, mobile net, and VGG16, and I had considered that these sum up to 1. And I had tried different manual weights like 0.631, 7 to 1. I will show this, and accuracy derived learned weights, so that it will automatically learn weights through the accuracy. And here you can see that I had used 0.631, 721, 541, and 0.35, 0.35, and 0.3, and it is trying to giving more weight to HOG and mobile net than the VGG. And you can see here that accuracy and when we are using some threshold value, our accuracy is getting increased. And I had tried this on different data sets like JP, KDAP, PrepDB, and CK plus. So adding a safety net confidence based restriction. So what we had done here at that, for the SVM highest predict protect probability for that phase, we are getting some confidence score for a particular predicting image, and we are setting some threshold value for that. It is, if it is below some that threshold value, we will reject that particular sample, and we can do a thing that we can choose some better model for that, or try some different approach for that. And finally we had reported that overall accuracy and the filtered accuracy. And here also you can see that for I had used different threshold values like 0.4, 5, 6, and 10, and we found out that 0.6 is working fine. And here it is automatically finding the uh, uh, best model for its prediction. And I had tried this on different data set. This is on KDAF and CQ plus and JFE data set. So here you can see that I had used different weights, and when after using the threshold value, our accuracy is getting from 91 to 98.57, and it is true among all the weights. And also we found out that best overall accuracy was 92.02 with weights 0.35, 35, and 3. Majorly we are giving more weights to HOG and mobile net. And best filtered accuracy was 98.69 with the weights 0.34, 33, and 33, which is basically the weighted average. And in the idea 2, emotion aware dynamic expert selection, in this our main idea was that for an individual emotion like happy, anger, sad, surprise, we will let the emotion to vote for its best expert model. Like for happy, HOG is working fine, HOG plus mobile net working fine, or HOG plus hybrid is working fine. And you can also see here that emotion aware dynamic expert selection network, I had also tried this on different data set, and I had used the accuracy and F1 scores for each different emotion, and it is automatically finding its best expert model. Here you can see that for indicate of data set, HOG hybrid is working uh, uh, best. And in the JFE dataset, you can see somewhere it is HOG, somewhere it is mobile net plus HOG, VGG plus mobile net, and HOG plus mobile net. And here also you can see that why different expert win for different emotions. So HOG is basically capturing the edges and the almost facial part. It is basically attention map for each emotion. It is showing that for each for an individual emotion, our model is focusing where, and this is one is for hybrid, this one is for VGG, and this one is for mobile net. And you can see that when we are combining all these three, it is capturing all the important parts of the face. So key takeaways from our these experiments, that confidence aware fusion is working. Our accuracy is increased from 91% to 98 to 99% on the reliable subsets. And there were balance beats bias in this, that near equal or weighted average one are giving some decent accuracy than the others. and so no single expert is winning everywhere. Like somewhere it is HOG plus hybrid, and in the JP dataset it is like HOG plus mobile net or VGG plus mobile net. So there were no single expert, and HOG, but we found out that HOG remains the backbone. It is the top tier expert in almost every case, especially on controlled dataset like CK plus, JFE, KDEF. Uh, so for the future work, we can extend our work to multimodal emotion detection like EEG plus face plus speech signals, and we can try this on wild datasets like RapDB, FER 2013, EffectNet, which are based on real world values, and we can do lightweight deployment like we can make real time of device facial emotion recognition so that it can be available in many fields, and we can also do learned router, which means that predicting right expert at the inference time so that we can know the values at the when it is just for the predictions, so no ground truth or label needed. So this will turn two mixtures of the expert to model. So thank you, this is all from my side, and from this I would like to end.